In geomorphology, we have already studied the river system, drainage basin, and today let us learn what is drainage line, drainage pattern, and drainage system. So, today main topic is drainage pattern. Drainage word comes from drain. Drain means there are two types of drain. Urban drain, in which there is one deep water outlet for keeping the surplus water from a lake or sewer out the city. And the second meaning is the drain in the rural areas through which rainwater passes through a channel, and this develops a drainage, and this drainage work is being used in different respects. For example, drainage line, drainage network, drainage basin, drainage system. So it is necessary to understand difference between these. What is drainage line? Drainage line is independent deep valley through which rainwater passes, and this is drainage line. What is drainage network? Drainage network or drainage net is the combination of a number of drainage lines. So this is drainage net or network. And then what is drainage pattern? There is difference between network and pattern. Actually, all networks develop a pattern. That's why here are written. But drainage pattern is a total glimpse developed, total picture developed by the meeting or combination of drainage lines. So this is drainage pattern. In world, all the rivers have developed unique type of drainage patterns because in nature there is no similarity. For example, if you take the face of two persons in world, there is no similarity or identity, and there is some or more difference between the two faces. In the same way, although nature has allowed all the drainage to develop its independent pattern, but there is no similarity, rather difference. But geomorphologists and fluvial geomorphologists have tried to classify the drainage patterns in main categories. So let us try to see. First is dendritic drainage pattern. Dendritic means, suppose this is the trunk stem or main tree branch, and its sub branches are these, which are meeting at a particular angle. This is called dendritic drainage pattern because it looks like a tree, major trunk and its tributaries. Its examples are Indus and Ganga. And for this you will have to do one exercise, that is drawing outline of drainage basins. As we have studied the drainage basin that was identical to the drainage basin of Tista. So you have to demarcate the water divide of all the drainage basin in the world, because sometimes questions are asked there. And second is here parallel drainage pattern. Suppose this is a sea and rivers are meeting the sea flowing through a parallel channel or parallel drainage line. This is called parallel pattern. And in Gangetic plain, this type of drainage pattern is visible. For example, in Gangetic plain, from northwest to southeast, a number of rivers like Ganga, Yamuna, Gomti, Ghagara, Kosi, these have developed a parallel drainage pattern. Next is here rectangular drainage pattern. Rectangular means this develops the shape of different rectangles. In rectangular, this has been drawn independently on a large scale because questions have been asked repeatedly from this. That's why its detail let us study here in this figure. Suppose this is a mountainous region, it slopes south, and according to its slope, the water of glacier or the rainwater drains southward, and it follows the main slope of the area. Thus, this river is called consequent river. And with this consequent river, at 90 degree, one river comes from this side. This is called subsequent. This is also meeting with consequent at 90 degree. Hence, this is also called subsequent. Why subsequent rivers will develop their drainage line? Its answer is here a fracture zone, or here the existence of weak soluble rock like limestone or salt-rich rock which are being dissolved away, and deep valleys developed through which rainwater drains through subsequent river and meets this consequent at 90 degree. Now next is, this is also following the main slope of the area, and it is not major river, rather tributary of subsequent. Hence it is called resequent. It is consequent, it is called resequent or reconsequent. Now there is one river obsequent that flows opposite the main slope of the area. Its cause may also be a fracture or weak structure, because its strike here is weak and its direction is just opposite the consequent, and this obsequent meets the subsequent at 90 degree. Thus, the entire picture developed by the drainage line is of rectangular shape. Hence, it is rectangular type of drainage pattern, which can be comfortably or easily noticed in Chota Nagpur plateau region. Next is here centripetal drainage pattern. Centripetal drainage pattern means if there is low-lying area in center and in surrounding it is highland, so during rainy season the rainwater from the surrounding highland form centripetal drainage pattern and fall here in the central low-lying basin or area. Its best example is Lake Sambhar in Rajasthan, in which a number of small tributaries fall in the low-lying this playa lake. And as we have studied all over world, all the playa lakes form this type of centripetal drainage pattern. Now next is radial drainage pattern. Suppose this is a mountain and rainwater will radiate from the peak of this hill into all directions. This is radial, or this is also called centrifugal drainage pattern. Its best example is Mount Amarkantak. Amarkantak in Madhya Pradesh, but along MP and Chhattisgarh border. So from Amarkantak peak, Narmada flows westward, Son northward, and one tributary of Mahanadi southeastward. Thus, that Amarkantak has radial drainage pattern. Next is here superimposed drainage pattern. Superimposed means the river has re-established its valley on its old course. For example, river Godavari is starting from Nasik, draining southeastward, and it has dug deep its valley, developed its valley completely, and it has attained the graded curve. But in the meantime, volcanic eruption takes place there, and the magma coming from the interior of the earth flows in the entire region and flows vehemently or rapidly in the Narmada Valley, because Narmada Valley is deeper and steeper slope. After cooling down of that lava, when it is solidified, certainly it will be solidified in Godavari Valley as well as in the surrounding area. But undoubtedly, the lava deposited in the original or initial Godavari Valley will be deeper, or its level will be lower than the vicinity or surrounding area. Now, rain god becomes merciful, rainwater falls, and what do you assume? The rainwater will again start flowing in the same river valley which is being covered with lava. So, during a certain period of time, that lava will be eroded away, deposited in the Bay of Bengal, and that river valley will attain its previous bed. This type of river is called superimposed river. Its best example is Godavari and all the rivers flowing in Deccan Plateau, but especially in the lava plateau region. Its other examples in world you can notice in the regions where there has been lava deposit and rivers have re-established their old course and old valleys. Now next is here annular drainage pattern. Annular means suppose this is a mountain as this was, it developed radial drainage pattern, but here in annular, suppose here you have developed a road for reaching its peak. Roads are not longitudinal, rather transverse. In transverse way, if there is some weak rock that is easily erodible, then the water coming from the top through radial drainage pattern will accumulate here and flow here like buses carrying tourists are moving. So this is annular drainage pattern. This is frequently found in the areas where radial drainage pattern is there. Next is trellis. It is found in mountainous regions where the rivers are flowing nearly parallel and they meet at 90 degree, means two rivers join it at 90 degree. So it is generally found in the karst structure regions, and here also rectangular drainage pattern like that is being developed, but these are not consequent, subsequent, subsequent and resequent. Now next is intermittent drainage pattern. Intermittent means, for example, rivers of Bhavar region. Now you consider that this is Himalaya region and rivers are coming from Himalayas and bringing down the circular boulders, and that circular boulder is being handed over by the river to the Himalayas at the foothill of Himalayas. This composite deposition is called Bhavar region. Bhavar region is very highland but depositional, and the river water is not seen flowing from through over this Bhavar zone. Rather, it becomes here underground, and after this Bhavar deposit, it is again seen at the beginning of Tarai. It is called intermittent river. The examples are the rivers of Bhavar. For example, there is a river Gola, and next is here antecedent drainage pattern. Suppose this is Himalaya mountain, this may be Indus, this may be Satluj or Brahmaputra, and you can define antecedent river as the rivers maintaining its own course in spite of a folded mountain rising in its course. For example, from Tibet Plateau, river Indus, Satluj and Brahmaputra come south and used to come south and drained into Tethys. Due to tectonic activity from Tethys, as Greater Himalayas started rising up, it rose comfortably up to the height of the southern margin of Tibet Plateau. But as the Greater Himalayas started rising more than the height of Tibet Plateau, it was subject to erosion by Indus, Satluj and Brahmaputra. With the result, they developed their gorges. For example, river Indus, Indus Gorge, Satluj or Sipkila Gorge, and Brahmaputra, Korba Gorge. So, one identity of this antecedent river is the development of gorge or canyon over folded mountains. Now, this is braided stream or braided drainage pattern. In braiding, in lower reaches, the main or trunk river is flowing in gentle slope area, and their deposition is also taking place. Due to it, the water of trunk or main stream is being bifurcated in 2 or 3 parts, but downstream, that bifurcated water again meets together and develops a composite channel. This is called braided channel. Its best example is Brahmaputra, because in Brahmaputra valley there are a number of depositional landforms as well as erosional landforms, and those easily bifurcate the water of trunk stream of Brahmaputra. Next is here underground drainage pattern. Underground means in karst structure, karst topography, where the water takes form of blind valley, it is invisible. But at the mouth of the cave in limestone topography, it is again visible, which attracts the tourists, visitors and worshippers. And its examples are Gupta Godavari in Chitrakoot, Gupta Dham cave, and all over world in limestone structure. So these are the types of drainage pattern categorized by fluvial geomorphologists. But in my opinion, the drainage patterns are as many as rivers. Now let us study the delta types, because from source to mouth we have already studied different aspects of fluvial channel, fluvial morphometry. But at last there is formation of delta, and the scientific study of delta is called deltology, and it is a part of sedimentology. There are different types of delta. We should not categorize nature. We should not put the nature in categories, but it is human effort, human habit to do it. So let us categorize delta. One is arcuate delta. Arcuate delta means this type of arc type of delta. And river Nile, river Congo, Rhine, Indus, Volga, these have developed arcuate delta. Where this Volga river is located, now it is your moral duty to see it on the map very clearly, whether in Russia, Poland, because questions may be asked. So for the development of arcuate delta, a number of conditions are required there. Means there should be surplus amount of sediment carried down by the river, and sea waves should also be smooth and regular. Next is estuarine delta. Estuarine delta, actually estuary is different term, delta is different term. First, let us understand the meaning of estuary and delta. Delta is a triangular shape deposit at the mouth of river near sea. When delta is developed, its best condition is very gentle slope and voluminous sediment load. At gentle slope, sea waves will continuously obstruct the sediment brought down by the river. Thus, triangular shape deposition will be found like this type of delta developed by Mahanadi, Godavari, Krishna, Kaveri along the eastern coastal plain of India. Contrary to it, the rivers falling suddenly in sea along steep slope cut deep valleys and water slowly and slowly falls from it. But after these rivers have dug deep valley, the marine water enters in it. This is called estuary, and the best or suitable position for the development of estuary is found in the western coastal region of India. Why? Because the western part of India was elevated due to plate tectonic activity. Hence, Narmada, Tapti, and other west-flowing rivers have developed their valleys. They are developed estuaries, not delta. But what is estuarine delta? It means this Narmada and Tapti have developed estuarine delta. Actually, after erosion, the west coast plain of India has become widened, and in this wide region, Narmada and Tapti have deposited and developed delta, not so extensive as those along the east coast plain. But the vertical erosion can also be seen in the western coastal plain, and that is called estuary, and that is termed estuarine delta. Question arises, why vertical erosion in delta region in west coast plain? There may be two causes. One, sea level decrease. Second, due to tectonic activity, emergence of land. So, first one is not suitable or correct, because these days sea level is not decreasing, rather rising. Thus, second answer is better, because the second answer is the emergence of western India, and it is true. That's why if there is question that how Narmada and Tapti have developed estuarine delta, explain, so you can answer in written or oral form to UPSC. So this is Narmada, Tapti. Mackenzie is also of the same nature, and Vistula, Elbow, and Hudson. Where Mackenzie is located, where Vistula is located, where Elbow and where Hudson. So these locations you find out in the world map, because questions may be asked in these, because these days all the river drainage basins are the target of planners, and this has applied fluvial aspect. Next is bird foot delta. You might have seen bird, their foot, and if they put their foot, the structure of that bird foot is found here in bird foot delta. This is also called finger delta, because the fingers of the bird foot are visible clearly there. Its best example is Mississippi. Why Mississippi? Because at delta, Mississippi flows for a long distance at sea level, and Mississippi in deltaic region has a number of distributaries which present a scene of bird foot. Next is truncated delta. Truncated delta means delta eroded by seawater. Sometime after the development of delta, there either tsunami or tidal waves or current or any type of man-induced tsunami reaches there and erodes the developed delta. This is called truncated delta. Next is blocked delta. Blocked delta means seaward growth blocked by seawater. The nature of delta is its progression towards sea. Means delta continuously grows and advances towards sea by depositional process. But marine waves obstruct it, and if marine waves are strong there, then the seaward extension of delta is being blocked, and this is called blocked delta. Now next is abandoned delta. Abandoned means renunciated or left delta. As we abandon our life partners, some people divorce, their wife divorces their husband, So this is human practice. From where we have learned it? We have learned it from nature, because we have taken all the things, habits from the nature, and this practice is being done by the nature. Abundant delta means once their delta was developed by river, but due to change in the course of that river, it has formed different type of delta. River Huanghe has bad name for changing its course and causing catastrophe and damage in the plain region of China. Hence, it is called sorrow of China. If a river can change its valley, its bed, then why not delta? And this is the reason that river Huanghe in China has shifted its delta. Towards which direction it has shifted, why it has shifted, its detail you should go through in detail. And next video in China we will be giving in detail. And now it is draining into Pohai, Gulf and Chihli. Thus, a number of rivers are changing their course and delta. So this is matter about delta. Now there are two more points. One, river profile. As we have our life profile means ups and down. You have career profile in high school 80%, in intermediate 90%, then in BA 60%. This is your career profile. In the same way, there is profile of topography or relief. Suppose there is mountain region, then valley, then mountain. In the same way, the politicians have also their career profile, sometimes top and sometimes in bottom. In the same way, river's profile is studied from its source to its mouth. And suppose the height of source is this much. Here on vertical scale, on y-axis, height is shown, and on x-axis, distance. And height and distance ratio is being used to show this profile, and this shows the slope, and on the basis of this river gradient or its slope is being measured, because somewhere here is a free face slope, somewhere rectilinear slope, somewhere convex, somewhere convex. And at the last, when profile of equilibrium is reached, this river is called graded river. And next is, suppose we are crossing the river valley. This is called cross profile. And in it, from one bank, go down at the bottom of this river if there is no water. And you again come up and reach here. This study of slope, this study of weighted perimeter and sediment deposition is called the cross profile. But if here is water and you become King Vasudev and carry Lord Krishna on your head, over your head, then you will measure the depth of water also, and this river will be Jamuna. This is called transverse profile, and this one was called longitudinal profile. And here on y-axis, this height, and x-axis, its width is being shown. Now last point is here, drainage system. You are aware of the term system. For example, camera system, projector system, computer system, our body system, nervous system, food system. System term is very common, used at crossroad by common person. But system, the scientific history of system is a composite picture consisting of a number of subsystems. Suppose your body system is here, then its subsystems are food system, nervous system, etc. That's why here system means one composite part which consists of subsystem. For example, river pattern, drainage pattern and drainage basins we study. So in India there are two types of drainage system. Number one, Bay of Bengal drainage system, and second one is Arabian drainage system. When you are writing the heading of Bay of Bengal drainage system, you should give the detail of all the drainage basins or rivers draining into this Bay of Bengal. While if you write the heading of Arabian drainage system, you should write the detail of all the rivers and drainage basins falling in Arabian Sea. So now let us move from India to world. If there is question that write a note on the Pacific drainage system, then in that condition you will have to put the map of Pacific Ocean and write the name and description of the rivers falling in that. And in these rivers, all the rivers from North and South America draining into Pacific, and all the rivers from East Asia draining into the Pacific will be included. Likewise, if question is there, write description of Atlantic drainage system, then you will write the rivers from North and South America draining into Atlantic, and the rivers from Europe and Africa draining into Atlantic. But if question is write note on the Indian Ocean drainage system, then you should locate the map of Indian Ocean and write all the rivers draining into Indian Ocean. And sometimes there may be question, write notes on the Arctic drainage system. In that position, you will have to see map of Arctic Ocean and write down the name of major rivers like Mackenzie, Ob, Yenisei, Lena, etc. But in Southern Ocean, there is no drainage system because from over Antarctica, only some glacial valleys drain into the Southern Oceans. That's why that is insignificant from this viewpoint. So this is a description of drainage pattern and delta types and river profile and drainage systems presented before you.